I just don't think one size fits all models are gonna work. If you start a new company, you want to do everything manually. It's okay, right? Just roll up your sleeves and do it.
Hello and welcome to another episode of the Accelerometer. I'm Dr. Matthew Merman, CEO and founder of Anarchy. Today we're going to be discussing narrow AI and open world AI with Oscar Beijbom, founder and CTO of Nyckel, a custom classification company. Can you tell us a little bit more about your work at Nyckel?
Right, so at Nyckel we arguably taking one of the most simple and straightforward, but also most broad use cases of AI and machine learning, which is classification of images and text. And we put the simplest possible API wrapper around that. So essentially, all we're asking you to do is provide some example inputs and outputs. We take care of training, finding the best model for your problem, deploying it. We also help you annotate the data, iterate on your data, and capture any issues as you go into production.
So what exactly does custom classification mean?
It means that you're classifying your own data into your own set of categories. So let's say, one of our customers sell these indoor gardens that are instrumented with it's like an IoT product that has a bunch of cameras, internet connection to it. And they want to say, if the plants are wilting, they want to send a little signal to the customer to know that they should water it. So that's an example of a custom classification, because if you send an image of that thing into, say, a pre-trained classification API, for example, Google Vision API, it'll just tell you plant and maybe room and like these sort of very generic labels that are associated with a picture. But that's not what they're interested in. They're interested in these particular aspects of the plant, right? So custom classifications means that you're training an AI on your own data to do exactly what you want to do with it.
Do most people have enough data who come to you like right off the bat to get something like this working?
Right. Yeah, so that's a common misconception. And when I started doing machine learning, I'm actually old enough that it's like sort of embarrassing to say, but it's like 20 years ago I started doing this. It certainly was the case that you needed thousands or tens of thousands of examples to get something real going. That's not the case anymore. So what we do at Nyckel, and I think what any reasonable actor would do, is you take models, whether it's for images or text, that are pre-trained on vast amount of data. So they already have a sense of the world, of the general concepts. And then you take those models and then you fine-tune them on the particular problem, right? Again, on the particular inputs and outputs. And in that case, you can actually get away with very little data. So we actually just require 2 examples per class to train the first model. And we typically see, up until 5 or 10 examples per class. That's usually good enough to go into a first production version with.
So would you say that what you've built amounts to having essentially built a foundation model for vision that you're then fine-tuning for specific cases?
Yes, that's correct. Yeah.
That's really cool.
And in that sense, we're an aggregator. So we have some models, foundational models that we train in-house, but we also source from other platforms, right? From academia, any open source product. We can just pull that into our infrastructure. And then what we do is actually we have a whole catalog of them and we train them all on your data, and we do it all in parallel. We actually spin up, I think, over 1,000 nodes instantly, train it all, just check which one works best, and then that's the one we pick for you.
I know in the case of LLMs and diffusion models, having data that is high quality turned out to matter a huge amount, even for the foundation models. One of the big reasons that people cite that Midjourney is more loved than DALL-E was because they decided to train it on beautiful pictures. Has that been something that you've thought about at all?
It's an interesting question. I mean, the thing that ultimately matters is, I think it's a little different when you try to train something that is completely general, sort of an open world AI. We can talk more about that later. At Nyckel, because we are training narrow AIs that is for a particular use case, the most important thing, the golden rule, if I may say, is that you train on data that reflects the data you'll see in production. So if your goal, if your goal is to generate aesthetically pleasing images, you should make sure to train on that. But if your goal is to generate sort of hand-drawn sketches, you train on that.
So it's not something that you're particularly concerned with at the moment because you're training more general purpose models than that.
Well, it's more like we're fine-tuning these general purpose models to a specific use case. So really the only thing that matters is that the data reflects what they're going to see when they use the model.
What was the hardest part about building these models?
I mean, for us, the challenge has always been we want someone without any machine learning knowledge to come in and actually train their own machine learning model, right? So what we found is that we kept reducing the amount of complexity that we expose to the developer. So a typical customer is like a CTO or senior developer at a small to medium size company. And these people typically haven't thought about what is a train split, what is a validation split, what is a test split, what are hyperparameters, what are regularization, what is a confusion metrics, like all these things that as a machine learning professional you're very used to talking about and reasoning around. So we said, let's just remove all of that and just have the cleanest possible interface that they can interact with. And that sounds easy. That sounds like straightforward perhaps, but it's actually pretty hard to make that user experience make sense to people, have the right level of complexity insights for them, so they appreciate what's happening, but at the same time don't make them stressed or confused about all these choices that they're not able to sort of make in an informed way.
What was your first insight that led you to this product?
Before this, I was, like I said, I've been doing machine learning for my whole career, like 20 years. Before this, I was running the machine learning team at the big self-driving car shop. So we had
one big one.
Well, it's called Motional, autonomy, and then Motional. Unfortunately, it's not very well branded or marketed, but they have a fleet of robotaxis in Las Vegas and also an operation in Santa Monica, LA.
I feel like right now you probably don't want to be well publicized as an AI self-driving car company.
Yeah, right now it's a little bit problematic, the space, for sure. But, so I had a team of 100 people, right? All the way from AI researchers to infrastructure engineers to data ops people to annotators and so on, right? And it was just an immense complexity to get this, essentially training one model that will drive the car, right? So, and then at the same time, my co-founder, Dan, he was on the other side, he's a generalist developer, and he had a site called What's That Charge? And he wanted to basically classify credit card statements as, or like text things as, is this a valid credit card statement or not? Because it was sort of user-generated content. And he was just like, how do I do this? It's so complex. You can go on, Hugging Face and find a model, but that's sort of just the starting point, right? Then you need to train it and tune it and deploy it and all that stuff, right? So I started helping him with that. And then I thought, you know what, this is like, you're right. It's way too complex. So so Nyckel was born out of that, to take people like him that are developers, or even, a lot of our customers are just product people, for example, and help them get access to state-of-the-art AI.
So how's it been going?
It's been going really well. We did Y Combinator a year and a half ago and got a really good growth curve out of that. And what we're seeing right now, what we're sort of trying to figure out is the breadth of use cases is crazy. We have marketing, operations company, we have sales triage use cases, we have Internet of Things companies, we have content moderation, we have augmented reality gaming companies. So, and I would say that every company in the world could essentially use, probably either are using or should use either text or image classification somewhere in their workflows, right? And so our challenge right now is just to say, we think this is a very broad set of use cases we can support, and how do we market that in an effective way, and how do we tell the world about that? So that's really our problem right now.
That's kind of a great problem to have.
Yeah, I mean, we're seeing. I'm not joking when I say we have 99% retention. So people like join us, they just stay forever. We had like one customer ever that left.
Do you know why they left?
No, I don't know why they left, because they, didn't reply to the "Why did you leave?" email. They're an Israeli web shop. They were actually, it's sort of hilarious. It speaks to the breadth of use cases. They had functions to screen out photos had screens in them or women in them, because in certain religious groups in Israel, you can't show women in screens in various I don't know the full context.
Like women with screens, or just like two separate concepts, women
I think
and
it was
screens?
two separate concepts, and neither was.
Okay.
I remember there was a big controversy in like the IKEA catalog, for example. I think in Orthodox Jewish groups, it got in trouble because it had women in the catalog.
Yeah.
So I think they had the same thing. Their web shop was catering to some of those communities, and they wanted to filter out those images. So again, it just speaks to the insanely broad range of custom classification like that.
Is that the wildest thing that you've seen somebody use Nyckel for?
No, I think some of the most surprising ones are people that look at basically statistics of data. So one company was building a diabetes. It's a tool that plugs into like a diabetes charting system, and that sort of analyzes the readings of the diabetes, the blood sugar readings to say, you're doing well, you're doing poorly, you should increase this or decrease that. And what they ended up doing is actually render that as a graph and just use Nyckel to classify the rendering of the data. And that was just kind of awesome that that worked.
I imagine there are a lot of other cases like that, like hacks where you could do it programmatically, but instead, it's just easier to pipe it into an image classifier.
Yeah. It's sort of.
Have you considered like making that like accessible through a library? Just like take it, like literally embedding it into the Python graphing library?
Right. PIL.
Yeah.
Yeah, I mean that's a good point. We actually have a Python SDK that lets you interact with the site, so we could add that. It'd be kind of funny actually. Yeah.
Yeah. I mean, if it works in that case, it might work in other
No,
cases.
and that's not the only one. We have another one that does air pollution in New York, and he has these particle meters all through the city, and he also used a similar concept.
I feel like I've seen such techniques be used in like gas chromatography.
Yeah, right.
Which is a very hard thing to say for me, but you're producing pictures that of like finite data, and you want to classify that, but most of it is done by vision.
Right. Yeah. So that happens a lot, but there's also really hilarious ones like there's one company is building they build sewage systems. So they use Nyckel to like monitor the flows. They have cameras in there, and they monitor the flows. Like, is this sort of trickling? Is it full flow? Is it stuck? And so on. So that's also very niche, very custom, if you will.
So once you have penetration and everybody is doing their classification through Nyckel, what would you want to focus on next?
Yes, our playbook is pretty straightforward. We want to be known as the classification API first and foremost to get that brand recognition. But the play from there is actually pretty straightforward. We want to essentially support all machine learning function types, right? So we think them as, so for example, text generation that is so popular right now. That's essentially a function type, right? Text in, text out. So we want to support that. We already have a few other function types. Actually, we have like detection of objects in images. We have OCR. We have
segmentation.
We don't have segmentation. But essentially you can enumerate all of these. There's a company called Eden AI who is, they're basically doing the same thing, except they are not doing anything in-house. They're just like an aggregator. So I think there's some merit to that. And then, of course, the challenge becomes, and we spend a lot of time on that with customers, like, so obviously you're familiar with what all these things mean, but we talk to someone who hasn't done any AI or computer vision, they say, well, you need they don't know what segmentation means. They don't know what classification or multi-label or tagging or, detection. So there's a bit of a onboarding problem there as well, a challenge that needs to be solved.
Do you find that most of your customers are non-technical and need this stuff to be explained, or?
Well, they're certainly technical, most of them. They're just not machine learning, trained in machine learning. Yeah.
No.
Yeah, like I said, I would say it's a 70-30 split. Between 70 are just software engineers, and 30% are product people or like operations people.
What's the point where your customers are just like, I need to use Nyckel right now. I can't do this on my own?
Yeah, it typically is driven by cost and by they. I think if you listen to take the words of wisdom from Paul Graham of YC, right? If you start a new company, you want to do everything manually. You just it's okay, right? Just roll up your sleeves and do it. But then at some point, as the company grows, you're gonna have to automate processes. So that's typically when they come to Nyckel. They have too much content that's put into the site, and they're just spending way too much time on that.
We were talking about at the beginning of the podcast the difference between narrow AI and general AI.
Right.
Is what do you see that as?
So when I say open world or general AI, it means an AI that basically should be able to handle anything you throw at it. It's not trained for any particular domain. And so as an AI that drives a self-driving car, I think of that as an open world AI, because you can't control what that AI is going to interact with, because you're driving around the city, right? Same thing with the GPT style API, where you train it to do anything, right? So you don't know what you're going to throw at it. And so that's on one side, right? And then the other side, you have stuff like Nyckel, where or any sort of task or task focused narrow AI. And to me, to me, the state of the art with machine learning technology is not mature enough to really convincingly solve the open world problem. And I think it's easiest explained in the context of self-driving cars, actually, where if you think about, there's always there was an open question for a long time in the field, where the deep learning technology was evolving pretty rapidly, the models becoming larger and larger, but at the same time, so they had more capacity, they could handle more stuff. But the problem is that the stuff they need to handle is sort of a combinatorial space, right? So you can imagine they need to handle all kinds of lights and weather conditions, like day, dusk, dawn, rain, snow, night, and so on. They also need to handle all kinds of agents on the road, obviously cars, trucks, bicycles, pedestrians, and then someone comes along on one of these like electric scooters, so then you need to add that to the taxonomy or skateboard. And I say it's combinatorial because you have to handle all of those categories in all the light conditions, right? And then you need to, for each of those, need to handle all the different appearances. So it becomes this exploding combinatorial complexity that even though the capacity of the models grow over time, I just think you can't really catch up to that. It's too much.
So with classification, isn't classification in some ways a superset of the text generation problem? At least in the sense that you could embed like the text that you haven't wanted to generate in an image, and then like make your classification problem figuring out what the next character should be, if you wanted to be very traditional complexity theory reductionist about it. So like theoretically you could just turn the text generation problem into a classification problem, at least an image classification problem, by like taking the text that you want the next character from, putting that into an image, and asking your classifier to give you the next character that should come, and you have finite like next characters. So like if you're going to have a foundation model for classification as truly generation or general purpose, you would also have to be solving the text generation problem, wouldn't you?
Yeah, I mean, I think that's interesting. I've never thought about
maybe
that
a
way.
little bit of a troll.
I like it. I always think of it the other way around, that you can, if you take a text generation model, you can do classification, right? Because you can ask it to classify things. It's sort of it's taking a bazooka to a knife fight, right? But I think you're right that ultimately they are doing classification. They're classifying the next character in a sequence.
Yeah, I mean, they're two sides of the same coin, right?
Yeah, I mean, they're all trained fundamentally, even though we call it generative AI, it's trained in the technical term is still discriminative, because it's trained, like you say, to classify, predict the next character after the other, versus an underlying statistic of the data. The underlying statistic of the data may be captured by the model in some sense, but it's not explicit in the model. As you think of sort of Gaussian mixture models or any sort of traditional generative models, yeah. So yeah, I think you're right. I think the only thing I would say to that is, from where I'm sitting today and where I see the the field going, the capacity of the technology as it stands today, I just don't think general one size fits all models are gonna work. And it's simple. One way to explain this is, so even let's say you want to use OpenAI to do something, right? What I always say, at the minimum, you want to at least, even if you're not going to train it or tune it or anything, you want to at least test it, right? You want to at least collect some data and say, here is what I'm going to say to it, and here's what I expect. So you can at least measure how well it works, right? And the thing is that once you have that, say you have 20 or 100 so those examples, that is actually enough to tune the model also with modern technology like fine tuning. So to me, there's like, I don't really see the reason for going all the way generic, because you need to test it, and once you have the test data, you can train with it as well using cross validation and stuff like that.
So what do you think is something that a lot of people in AI, either AI researchers or founders, are getting wrong right now?
That's a good question. I mean, I don't know. I've been through, for the last 10 years, we've been through 3 hype cycles, right? The self-driving car hype cycle, which as it stands right now, maybe doesn't amount to that much, or at least for now, not that much have come out of it. And then you had the NFTs hype cycle that also seemed to have not generated a lot. And now you have the generative AI hype cycle. And my only concern is that, people are jumping onto the technology hypes rather than like the problems they're trying to solve. So now everything has to be solved with generative AI, and that's like the only way you get VC funding. So part of the problem is actually the VC community, and that they have this herd mentality, that like FOMO mentality, that's just whatever, like I just want to own this latest trend. So that's, it's been really hard for us actually to say, okay, we're not going to do generative AI because there's so much buzz around that, because we still think that for the most part, I mean, there are certainly use cases for generative AI, like chatbots and document search or sales and marketing content generation, right? But I still think that there's a much bigger space in classifying, like decision making based on data, because ultimately that's what you need in your processes in a company, right? You want to ingest some information and then make a decision based on it. So that's why we're sticking with decision making or classification.
So what's something that you're excited about for the future of AI?
I mean, I really like what are they called? DeepMind, right? So Google bought them, and I think now they're a little bit more integrated. For a long time, they were just operating independently, and I always really appreciated that type of ML research, and it was like, specifically, they do a lot of reinforcement learning. And to me, that's like the closest thing you get to sort of magic still in the AI world. And I think they do amazing work, and they're able to like really generalize to, they do protein folding, and they play StarCraft 2 and Go. And, I think that is still really exciting to me.
What do you think the state of RL is at the moment?
Honestly, I don't know. I don't stay on top of that so much.
Yeah, I feel like I haven't paid much attention to RL in the last 5 years, and I feel like we all just kind of forgot about it as a field.
When deep learning first came out, like 2012, 2013, like it was said that there was 3 people in the world that could train a deep neural network, right? That was sort of so I was doing my PhD at the time. I didn't even try, because it was like, it felt like it was so far away. Like the tooling was so terrible. And to me, it feels a little bit like that with deep reinforcement learning, that the libraries, and not just the libraries, but the methodology, people came up with batch normalization for training deep neural networks, and that made it just more friendly to hyperparameter tuning. You were more likely to be in sort of the sweet spot where this actually trains. And there's there's 10 or 20 hacks like that, or hacks, or just technology breakthroughs that makes it a lot more accessible. And to me, reinforcement learning is still like in that early stage, or maybe it's partly because I'm not that deeply embedded in it. But it feels like to really make it work, there's still a lot of sort of insider knowledge that you have to get right, because the distance between the reward, right, and the model, the weight updates is so long, right? You do these long rollouts of action sequences, and then something happens. You have to sort of really capture that signal and trace it all the way back. I think that's hard. It's really hard. I think DeepMind are doing some pretty amazing work there.
Yeah. I remember when I was doing RL research like 6 years ago. We basically gave up on it. We spent like 6 months. We must have sunk like $300,000 into like compute resources
Right.
for training, and we ended up with this giant spreadsheet of like completely unpredictable high variance results because you just couldn't do enough of the training runs, and they took so long.
Yeah.
So you could do like 20 experiments with that much money over that amount of time. And
Yeah.
you just never knew what the right direction to push in was.
Right. And so I have a really funny anecdote from that world when I was doing research at Berkeley for a while. And so have you ever been to Berkeley, like the AI building there?
I've never been to the AI building, but it's a beautiful campus.
Yeah. So the AI building is hilarious because it's this really prestigious things, right? There's like Michael Jordan is there, like the AI Michael Jordan and Jitendra Malik and Aliasha Efros, and like there's all these Peter Beal, like they're all right there, and all these grad students are clearly brilliant and postdocs, but everyone's crammed into these really tiny spaces, and it's like really dingy everything. There's like just cables everywhere. There's like
it's a public school.
Yeah, this cable is just like so crammed. I couldn't believe it. And then so I'm sitting in this little cubicle and in a row of cubicles, and then right behind me are some robotics people that are doing reinforcement learning on real world robotics, right? And that's famously hard, right? Because to model all the little mechanism plays and issues, delays of a real world system is super hard. But they had this was maybe 5 or 6 years ago when they were starting to see breakthroughs in deep reinforcement learning. So they were just sitting there for weeks. They had this little robot that was like this tall, and for the most time it was hanging by the scruff of its neck in like a tripod because it couldn't stand, right? And they were sitting there like coding, and then they would like put it down, and they would just like boink, fall over, and then they would like work for a day, put it down, like boink, fall over, and they would hang it by the scruff of the neck. And so when I was sitting there like late, it was like maybe 11 or 12, midnight, and I just work on something, and I look over, and all three of them are just sitting like this, like in a circle around this tiny little robot hanging, again by the scruff of its neck, and they're just quiet, and they're just like giving up. There's just like nothing, just like. And it's just so like, I don't know. It's so symptomatic of doing research in that field. Yeah.
That's the general world's like approach to RL.
Yeah.
And also, I guess self-driving cars probably.
Yeah, but we weren't really using reinforcement learning there. Like,
but it's robotics too,
yeah,
right?
You're right. Yeah. You're right. And I think, arguably, I mean...
Like, how many cars can you crash on the way to building a proper self-driving car?
Yeah, right. And in fact, I think... so, do you know who George Hotz is in Com.ai? Yeah. So he... I think they're doing it right. I think he saw it very clearly, very early that... I'm still not sure if it's going to work, but if it is going to work, it needs to be like an end-to-end optimized system, right? Where the AI reads in the pixels or the LiDAR scans and outputs the controls directly. So the way he was able to do that was bootstrap it through like an autopilot type system. I think it's called OpenPilot. And bootstrap a bunch of data and actually train these things in a very, I think, a beautiful way. Like it's sort of, he's making money the whole time and like kind of careful. It's just a refreshing contrast against what everyone else was doing, which taking in billions of dollars and just throwing it on everything, except, but anyway, so if you're doing it that way, you're approaching reinforcement learning without having to actually crash the cars.
So what was your team working on when you were doing self-driving cars?
Yeah, I mean, when I first joined, I always say that like computer vision is sort of the gateway drug to for ML to come into robotics, because for a long time, obviously, if you're using LiDAR, you can reason explicitly about LiDAR scans without using machine learning. So for a long time, you could build, people were building self-driving cars without any machine learning at all. It was just quote unquote probabilistic robotics based on explicit reasoning of LiDAR scans. So I came in to do, but then at some point you need computer vision. You need to say, is this a light like pole or is it a pedestrian, right? And that's pretty simple with the camera. So I started building up that, joined as a research scientist to do that. And then very quickly that became like a machine learning team to solve the computer vision part of the pipeline. And then as the field progressed, we just said, well, we kind of glanced over at the LiDAR pipeline and said, I think we can do that better with machine learning. So then my team was started looking at that, and we published a paper called Point Pillars that is, I think, one of the most cited methods for doing object detection in LiDAR point clouds. So then we deploy that, and then we do the same thing for radar, and then you do the same thing for the tracker, and suddenly like the AI is sort of eating up more and more of the stack. But it was, it's sort of slow going because everything has to be very careful. And there's some real merits to having explicit reasoning in the planner and the controller, because you can debug it a little bit easier. So it wasn't like as straightforward as I make it seem, but at some point, when you have that much higher accuracy or prediction quality, then you just kind of have to go with AI system.
Is there anything about the future of AI that worries you?
Not really, to be honest with you. I mean, yes. Okay, so yes, there is something that worries me, and I think the misinformation campaigns. So when people talk about AI threats, there's like tiers of threats, right? And the lowest tier threat is this misinformation threat, which I think is very real, and it's just obviously getting worse by the minute, right?
But it's also the lowest tier threat.
Yeah, it's sort of the lowest tier threat, right?
Yeah. I guess the lower the threat, the more real it is, right?
Yeah, I suppose so, yeah. I mean, or fortunately, it's not always the case, I suppose, right? I mean, there's a real threat of nuclear bombs. That's a real threat. It's a really bad one. But in the scope of AI, I think so then people worry about these super intelligent. Oh, okay. So there's that threat, and then there's the job displacement threat, which I don't think there's a lot of merit to. I think it's like any other technological breakthrough. It'll displace some jobs, create new ones. And also, if you look at, the adoption rate is so slow for even just software. Like, I feel like hasn't been rolled out fully in like industry, right? You look at some bigger companies and their processes, they're like, Jesus, why are you doing this manually? Like, you don't need AI to do that. You just need like a programmer. You just need like some simple scripts or automation, right? So I would say like even software hasn't penetrated. So the machine learning and then AI, but like that's going to take a very long time. And then of course the big one people are worried about is this overlords, the like singularity with AI becomes smarter than humans, then it trains itself and sort of takes over. And I'm so confused by that because I don't understand. There's so many leaps of faith you have to take from the current technology, which is literally just a neural network that can predict the next character in a sequence of characters, to something that's like, and you can fool it really easily, right? You can there's like obvious bugs and issues coming up every day, and it's out of domain, and then it doesn't know what to do. Take that to like some sort of super intelligent reasoning, general AI in a real sense. I don't understand it, honestly.
I think the thinking is, we've come so far in the last like 2 years. Like we basically hadn't solved text, hadn't solved natural language at all. And now we have something which, in some ways it's dumber than people, but in other ways it's really quite fast, and fast is a large part of what we consider intelligence. So it's not just fast now on things like chess, but it's fast on creative tasks, and fast on even some reasoning tasks. Like you can ask it to read like Charles Dickens, an entire book now, and then ask it like a reasoning task about something in the third chapter, like on the 30th page, and it might give you like a good answer that would take a human like a week to find out.
Right.
And the thinking is, given that we've come that far in 2 years, and given that we've come like less far than that in previously, what if it gets twice as fast next year?
Yeah, so first of all, I don't think it's 2 years. I think this started like 2012, right?
Yeah.
And the Transformer maybe a few years later. So I would say it's like 10 years. And of course, like the general public got aware of large language models once ChatGPT was launched. But it's been a very gradual improvement of that technology. And it's fast. Yeah, all computers are fast. That's like kind of what they do, right? But to me, the leap of faith of, and so yeah, they can synthesize Charles Dickens. They may or may not get it right. They may or may not cite the right pages. It's just a really thin facade of like reasoning, in my opinion. It's not real reasoning. So that's only half the problem. The other half problem, this is George, again, like George Hodge did this podcast, he was on Lex a while ago, and he pointed out sort of the obvious thing about reproduction, how sort of the silicon stack of life or of intelligence is like, can't reproduce itself, right? It would have to be, or rather it can, right? But it's really roundabout. They have to basically embody a whole factory, like a whole like silicon production factory, right? Versus the biological stack started with reproduction. So it just seemed like inherently more robust. So if they somehow magically become super intelligence, they still don't know how to reproduce in a sort of robust way. So that makes me even less worried.
Have you been keeping up with the recent AI regulations?
No, I just see this flicker by. But from what I understand, it's not good. It's like, I mean, because I'm not worried about AI, I don't want any regulations on it. Like, I don't understand what they're doing.
So fewer regulations would be good.
I think so. I think it's, I don't know what we're regulating. Like, because there's nothing to be worried about. It's very strange to me, the whole thing. What is the...
I mean, I generally agree. It's less though that I'm worried that there is nothing to regulate, but my fear is that we have just done such a horrendous job of regulating in the mass. Even when I just look at these regulations, they're just like, and no training larger than this model. Is like,
yeah.
How is that? Like, why not just say, don't train systems that kill humanity? I mean, right. We kind of, the problem is we already have regulations about that. We already have regulations that say corporations should not murder people. Right. Like, that's enough for me.
Yeah, right, yeah. And I think you can put in regulations to place around, obviously around misinformation and how some of these models are applied and used. The rights of artists, for like that these models, like the content of music, whether it's music or art that these models are trained on. Of course, that's like, that's important. And that's very real and happening right now. But to go off on, and I don't really, so what confuses me is they have smart people like Jan Kuhn, who is sort of on the same side as I am, where he's sort of the champion for like, let's not worry about this movement. But then you have like Sam Altman and George Hinton that are suddenly really worried. And it just doesn't compute because they're obviously really smart people.
Well, Sam Altman, we can write him off as being self-interested.
Yeah, that's fair enough.
But yeah, Jeff Hinton, that's harder to explain.
Yeah.
Like, he literally wrote the papers, like inventing the neural networks. If he's worried, you wonder to yourself, like, maybe I should be worried too.
Yeah, and I was all worried. What?
Yeah, my feeling is I haven't gotten my AIs to kill me yet. So until then, I'm not going to worry.
I mean, I think once you've been in the industry, it's hard to get these things to train. Like a lot of times you just train and the loss goes to zero, and some layer just nans out or max out, and then you get nothing. It's so brittle, the whole thing. And of course, OpenAI did a fantastic job making a very polished product out of that with this reinforcement learning from human feedback. Make it sound very human-like. But I think people are going to be disappointed. I don't think they're going to get much better going forward. I think they'll be able to ingest images. I think they'll be able to do like more modalities. But as far as the raw like reasoning, it's not going to improve fundamentally. That's what I think.
I've actually felt that the RLHF has made these models worse. I felt that they were more natural to talk to like a year ago.
Interesting.
I mean, right now with the RLHF, you talk to a model and most of the time it's just like, no, I don't feel like doing that. A human wouldn't do that. A human would be like, it would steer the conversation away from it in a natural way rather than be like, no, we're not talking about this right now. This conversation is over.
That's interesting. Yeah, I haven't thought about that.
Like a human would get uncomfortable talking about it.
Right. Yeah, and I think it's it's hard to know whether what's called
RLHF.
RLHF, where that starts and where like sort of explicit gating begins, right?
Yeah.
Because they have obviously keywords in there that trigger certain responses and all kinds of rules. And what do you make of this? First rumors, then evidence that the actual output was worse for GPT-4 when it came out, passed all these tests, and like.
Well, I mean, I think they want to cut costs. I think that's clear.
Okay, so you think they're just running smaller versions or
more
like
quantized versions.
distilled versions?
I mean, maybe more RLHF. I don't think that they would RLHF the model to like be worse. Like, I think that they're probably only RLHFing the model not because they care that much about safety, just so that they can say that they're caring about safety.
Yeah.
Like maybe they're upset about certain inputs, but like how upset? Like upset enough that they'd want to reduce the performance of the model.
Right.
To me, it just makes sense. Like they found optimizations which most people are fine with,
Yeah.
and that's saving them millions a year.
But that's the confusing part because do they need to say millions a year? Like,
I've heard it's extraordinarily expensive to run these models at their scale.
okay.
Like they have the largest model, and like they're charging very, very little for it. I heard, like my understanding was that until recently they were losing, and they might still be, but they were losing money
Okay.
on
Yeah.
inference.
Yeah, okay. It's just yeah. But it still confuses me that, there's like there's a benchmark suite of tasks, right? LLM type tasks. And they go from being, whatever score, like 98 to 14. Like why would you roll out that update even to save money?
Because that intelligence isn't important to most people's use of the model.
Yeah,
That's my theory.
yeah,
Like,
yeah, okay. Yeah.
I think the people who that's important to are the people that are competing with OpenAI. So if you're using OpenAI to build some sort of like AI reasoning agent and you're using their APIs and you need that reason for something like Sirius, you're probably going to be a competitor with what they're doing. So they don't care about you, but what they care about is the people that are just like doing summarization tasks from like large bodies of text and spending a huge amount of money on like these dumb AI natural language things. Who knows what's going on with GPTs or whatever they rolled out 2 days ago. But yeah, I think the existence of that rollout, like, kind of validates that point that, they're working on other products that will take advantage of the reason.
Right.
I try not to worry about it and try not to position my business at least so that like OpenAI is just decidedly not a competitor. But who knows? Maybe they'll get into open source LLMs.
Yeah, what are your thoughts on Hugging Face?
On Hugging Face? Hugging Face is great.
They're the good guys.
Yeah.
Yeah.
I don't know whether they're the good guys, but it's a lot of models and they're useful and they're hosting them. So that's nice.
Right. They do come across as genuinely, quote unquote, well intentioned and sort of the open source. Yeah. No, I tend to agree with that.
It was really nice having you on. I think this was a fantastic conversation.
Yeah, thank you.